Hello students, this is a video review of the problem sets from Unit 1, Lessons 5 through 8. Hopefully you tried the problem sets already. You can take a look at those now if you haven't already done so. Let's start with problem set from Lesson 5. If you haven't done these problems, pause the video, take a second to try to do them, and then come back to see if you're right. Alright, here are the correct answers. Looking at Section A of problem number 1, QB is the bisector of AQC. A bisector means it cuts it in half. That means that these two parts of the angle are both equal to each other, and they're equal to half the whole angle. So if the whole angle here is 35 degrees, that means that each half of the angle is going to be 17.5. Notice that we set up the equation, we substituted into the equation with the information that we had, and then we solved the equation. For letter B, it tells us that these two angles are, well, it gives us their measurements in any event. We know the addition postulate means that these two angles next to each other are going to be equal to the whole angle. So we wrote down that JIL plus LIK is equal to JIK. I substituted in the values, and now it's just an algebra problem. We solve for x, and we get x equals 5. The question asks us to find the measure of angle LIK, so we substituted 5 into LIK to get our final answer. Moving on to letter C, it tells us that DE bisects AB at F. Now, it tells us this very specifically. DE bisects AB at F. It cuts AB in half. It doesn't say that DE is cut in half. It says that AB is cut in half. So we know that AF and FB are going to be equivalent to each other, but we don't know that about FE and DF, and we don't know that about AF and FE. All we know is that AF is the same as FB. So we don't know either of those to be true. For number 2, it tells us that it's an angle bisector. I gave some notes here. Cuts it in half, cuts ABC in half, and it asks us to find something specific. So we tell the grader what relationship we're using. We set up an equation, we substitute, and we solve. And here we took that value of x, substituted into the original expression here, and we found our answer. We did the same thing for number 3. Addition postulate just says that these two adjacent angles add up to the large angle that they make. So we stated the relationship, we set up the equation, we substituted values in, and then we solved. And then once we got that value of x, we took that value of x and substituted into 3x plus 1 because that's what QSR was equal to. For number 4, it was a little bit different. It did not give us a diagram, but it tells us ray BX, which starts at B and goes through X, is a bisector, which means it cuts it in half, of angle ABC. So I drew angle ABC, and ray BX, which bisects the angle. And it gave us some values for the angle, so I labeled my diagram, and then found the two answers that it was looking for. First, we solved for X, and then we identified the value or the measure of ABC. Keep in mind that you should be using degrees when we're talking about the measures of angles. In every case that you can, include the units for the measurements. Moving on to the second page of the problem set from Lesson 5. Pause the video, try them out, and see if you got them right. You can see that question 5 is very similar to the previous questions. We're using the addition postulate saying that the two angles that are adjacent to each other add up to the larger angle that they create. So we substituted those in and solved for x, and then used the value of x to find the measure of angle NFE. For the next couple of problems, we are still using the addition postulate, but this time we're using the addition postulate for segments. We did a lot of work here to find the value of x, which is equal to -3, and then we see that it asks us to find AC. Well, it turns out that they told us AC in the problem, LOL. For number 7, we have this line segment, ABC, and we're told that AB plus BC is equal to AC. That's the addition postulate. We substitute, solve, and substitute again. Question number 8 is very similar. We have the whole length here, and then we have the 3 segments that make up that length. Substitute and solve. Question number 9 and question number 10 were very similar. The only difference between the other problems in question number 9 was that there were multiple equations that were going on. We know that BC plus CD is equal to BD, so we set up that equation and solve for CD. And then we also know that CD plus DE is equal to CE. We set that equation up and solved. Once we found that information, once we found that x is equal to -12, we substituted that into an equation and solved for CD. Now keep in mind, it will tell you to find one specific line segment, so if your answer doesn't have that line segment, you're not done. It gives us another description but no diagram here. For question 10, we draw the diagram, label it up, and it's pretty clear that all we need to do is find AC, the missing part of AE, which means we use the addition postulate again. Moving on to the problem set from lesson 6. This problem set was talking about the relationships between angles. Pause the video, try it out, and then I will show you the correct answers. Here they are. Supplementary angles here, the two angles are alongside of a straight line. That means that the sum of their measurements is equal to 180 degrees. In this case, I made it real simple. I said angle plus angle equals 180. This angle and this angle is 180. I didn't have to name the angles. I didn't have to say angle A, Q, X, or whatever it is. I just said angle plus angle equals 180. I'm going to be using that for the rest of the time here. 144 plus A, those are the two angles here. In this case, it was supplementary with these three angles, so I did angle plus angle plus angle. Hopefully you get the idea. In this case, it's complementary because this side is 90, which means if the whole AB line segment has 180 degrees on one side, that means this side has 90 degrees as well. It is a right angle. So I showed angle plus angle plus angle is equal to 90. Substitute, solve. Same thing here, or similar thing here, we have supplementary three angles together equal 180. In this case, there was a little bit more algebra because we had to divide by 2. But no big deal. Angle sum of points says that all of the angles around a particular point that share the same vertex is equal to 360. If you remember these numbers, angle sum of points is 360, supplementary is 180, complementary is 90. You should be good to go. Here again, we did some algebra, but luckily, we were able to do that algebra pretty effectively because you passed algebra before, remember? Angle sum of points, there's 4 angles here. Added them all together, equaled them to 360, and solved for x. This says x is equal to 80 degrees. If you wanted to find this angle as well, that must be 80 times 2, which is 160 degrees. Moving on to the back of this problem set, pause the video, try these out, and then come back and see if you got them right. Here we had two different relationships. I think that in all of these questions, we have two different relationships. We had two angles that were supplementary, added them together to equal 180. It turns out that these x's eliminated themselves, plus x and minus x. So that meant that all we had to do was find that y was equal to 90 degrees. Once we found that, we knew that these two angles, 2x and y minus x, were vertical angles. We substituted them into the equation for vertical angles. Then we solved for x. Here again, we knew supplementary angles, these blue angles, they all add up to 180 degrees, so we found x. And then vertical angles, we know that these two angles, this angle here and this angle here, are both 90 degrees because they share a vertex and they're created by two intersecting lines. For this one, we only needed one relationship supplementary. These three angles along one side of a line are equal to 180. Here again, we had vertical angles. We said that these two angles were equal to each other, the 3x plus 6 and the y. So all we said was, well, y is equal to 3x plus 6. We needed to do that because supplementary angle says that this angle, and this angle add up to 180. So we substituted and solved. For number 11, I hope by now you're figuring this out. Supplementary means angles along a line. So here, here, and here, there are three angles along a line. Add them together, equal 180. The last part of this question asked us to do angle sum of points because all of the angles around this point here are equal to 360. We substituted and solved. Here again, for this problem, we used vertical angles. We said that this angle over here is equal to this angle over here. Those two angles are equal to each other, so we substituted and solved. Supplementary angles here, 68 and y are supplementary, which means y is 180 minus 68. I didn't show the algebra steps in here. I didn't show like, oh, minus 68 on this side, minus 68 on this side, because by now you should know how to solve 1 and 2 and 3-step equations pretty quickly. Moving on to the lesson 7 problem set. This was one of the problem sets that required a compass. Now, if you don't have a compass at home, I wouldn't panic, but it's a very good idea for you to go and get a compass so you can practice these at home. These are not like the easiest things in the world. They're very straightforward, but they're something that require practice. Pause the video, try these out, and then come back and see if you got them right. In each of these problems, it asks us to bisect an angle. Here we bisected the angle by drawing an arc, putting the compass point here and drawing another arc, putting the compass point here and drawing another arc, and then bisecting the angle by drawing a line segment. The use of the compass is not something that you're going to learn just by looking at it. You definitely have to try it out. Speaking of the compass, here is the electronic version of the compass that I use. It asks us to construct the angle bisector of angle D. So the first thing I did was I put the point on D, and then I used the compass to draw an arc here. Once I drew that arc, I put the point on the arc, and then drew another arc. Then I put the point on the other arc. Notice where I'm putting this point. And then I'm going to draw yet another arc. These arcs are only going to intersect at one point. That's here. And that means I'm going to connect the vertex with that point. Done. Moving on to the back of this problem set, pause the video, try it out yourself, and then come back to see if you got it right. This question tells us that we're looking at a sector of a circle. We haven't gone over this word sector yet, but that's okay because you don't need to know that. All you need to know is that this is an angle and you can bisect it. Construct a line that represents all points equidistant, same distance from MN and MP. We're supposed to construct a bisector, so that's what you should have done. Then would a reflection across this line map the figure onto itself? Well, if it's mapped onto itself, that means it overlaps perfectly. It turns out that yes, if you reflected N over this line, it would reflect perfectly onto P. All the points along here would reflect perfectly along here. So yes, it is mapped onto itself. For question 7, you can split an angle into 2 equal angles, but you can't split an angle into 3 equal angles because once you cut it in half, you can't suddenly take that and turn it into 3 equal pieces. You can cut an angle into 4 equal angles. You see it right here. I bisected this angle and then bisected each of the remaining angles. I could keep doing that over and over and over again as many times as I want. Here I made 4 equal angles. I could bisect this one, this one, this one, and this one to make 8 equal angles, then 16 equal angles. I'm just multiplying by 2. They're multiples of 2. And then for question 8, that's very subjective. In my own words, I am extraordinarily comfortable with using the compass because I teach this class. But hopefully you're getting more comfortable with it as you practice. Moving on to the last problem set. This is the problem set from lesson 8. Pause the video, try it out, and see if you got them right. Here's angle HJM. Now remember, there were a couple of steps in order to do this. It would be a good idea for you to memorize these steps because the unit test coming up is going to require you to know these steps. Step 1 was to make an arc, this red arc here. Copy that red arc over here to a new point. Step number 2 was to draw a line segment. This line segment is already here. I drew any old line segment that I wanted. It doesn't have to be the same slope as the original line segment, just any old line segment. Then for step 3, copy the spread. Remember that spread is a measure of how open the angle is here. Let me see if I can show you with the compass. The spread is from here, from this point, over here. Come on, compass. Over here to this point. That's a measure of its spread, how far it's spread apart. Then I copied that arc over here. Once you copy the same exact spread from one angle to the other, you should get the same exact angle. It makes sense because that is the amount of spread or the amount of openness that the angle has. And then once you're done, you have 2 intersected arcs. Well, guess what? Connect the dots. For question number 2, it asks us to first bisect the straight angle. You could have done that using the skills from the last lesson, and then copy the angle. You use the skills from this lesson. And then for question 3, it asks us to construct a copied triangle, a congruent triangle. I copied the length of both sides. It was the easiest way to do it. Copy the length of ZY and put that arc here. Copy the length of XZ and put that arc here. They only intersect at one point, so this triangle and this triangle must be the same. Again, I took the compass and made it equal length to ZY, like this, and then I copied that length exactly over here. No big deal. For number 4, the top and bottom will be bisected. It looks like they're bisected here. We cut them exactly in half, but these left and right sides are not bisected because these 2 angles are not the same. All right, this was a review for the problem sets from lessons 5 through 8 in Unit 1. Good luck studying.